Alright, welcome again to Physics Academy. We'll carry on with our next lessons, which is the second part of resultant forces. So in the first part of the resultant forces, we have seen that we can actually add two forces. When we have two forces acting onto an object, we can add them up together if they are acting in the same directions. So for example, you have a 10 Newton force and a 5 Newton force acting both to the right. So as a result, or we call it as a result, or we can call it resultant force, that is acting onto the object will be given by the sum of the two forces which are acting in the same direction. So in this case, there are only two forces. So the sum of the two forces will be 10 Newton plus with 5 Newton, which will give you a 15 Newton, which as a result will also produce a result which is a force which is to the right also. Right? So there are also cases sometimes where the force acting or the forces that are acting onto the object, they are not acting or pointing in the same direction. They are opposite in their directions. For example, let's say you have an object. So usually, as a simple idea, we will use an object as a box. That will be the basic idea that we can use always. So there is one person trying to push the box forward with a force of 10 Newton, and the bench, which is rough and has a friction of 3 Newton. So we know that frictional forces are all forces that are acting in the opposite direction of the applied forces. So this is a very, very important concept that every student should know. The friction forces, friction or air resistance or water resistance or resistive forces, they are all known as resistive forces. They are known as resistive forces. Why they are resistive forces? They always tend to either slow down or go against the applied forces. So in our case, the applied force is the 10 Newton. This is the applied force. So there is a friction that the bench have with where the box is touching the surface. There is a friction maybe of a value which is 3 Newton. So we know that since there is a friction of 3 Newton, so the 3 Newton should be acting in the opposite direction of the applied forces. And they always act in the opposite direction. So that would mean now we can actually come up with the result of the force that is acting onto the box. We know the forces that are acting onto the box. We know there is a 10 Newton force applied by maybe someone who is pushing the box, and there is also a force which is applied onto the box by the roughness, the surface roughness of the bench, which is against the applied force, and 3 Newton. So there is a 10 Newton forward and a 3 Newton backwards. Or you can say that 10 Newton to the right and 3 Newton to the left. Right? So by visualizing this idea in terms of vectors. So in terms of vectors, what we can do here is in terms vector. We have seen previously that vectors we can represent by line and arrow. So we need to choose a scale first to draw them. So you choose a scale. Let's say 1 centimeter represents 1 Newton. So earlier we have seen that for vector addition, for the addition of forces, we add up the forces by joining the two vectors. So now we will be also joining the two vectors, but bear in mind the directions. So let's say we have a vector which is a 10 Newton. So we will draw a 10 centimeters length of line. and pointing to the right. So it should be 10 centimeters pointing to the right. The length of the line must be 10 centimeters. And joining this with a 3 centimeters line, but the line must be pointing to the left. 3 centimeters. So finally we can see that the end of the joinings, right, when we join the two lines, the end of the joining is nearer now. It's somewhere at this point here. And this point, if you measure the length from the starting point until that line, if you measure this length, it is only 7 centimeters. So this result of the two values, 10 and then you minus 3, you get a 7. That is the resultant force that is acting onto the box. So that means the force resultant acting onto the box is equals to 7 Newton. But it is still 7 Newton, which is to the right, because the position is still somewhere on the right from where we started our drawing. This is the point where you start your drawing. Right? By using the mathematics, okay, mathematically, we can also do this as F resultant. So I will use a subscript R for the resultant, will be equals to, we have a 10 Newton force which is acting forward, and we add up with a 3 Newton force which is acting backwards. So since it is acting backwards, a negative sign is added. So therefore, as a result, you will get a 7 Newton force, and it is a positive value. So positive represents to the right. So commonly, what we will be using here is that the positive directions are all the rightward directions. That is the what common interpretation of, or we can say logically thinking, to the right are positive and to the left are negative. Right? But it doesn't mean that a student must follow that concept. Right? You can also assume that to the left is positive and to the right is negative. You will never be marked wrong, because that is all your interpretation of the forces. But we will go with the common application of it. Common application of it will be to the right is positive, to the left is negative. Alright, let's go with another example. Let's say you have a box. Say example number 1. Now we go with example number 2. There is a box, or instead of using a box, let's change our idea now. There is a ball which is falling downwards due to its weight of, let's say, 5 Newton. And as it is falling, it is also experiencing air resistance. Air resistance of 2 Newton. Right? So what is the resultant force acting onto the ball? That is what we are concerned here. Right? So we know that there are forces acting onto the ball. So what are the forces? There is weight and there is also air resistance. So those are the forces. But what is the result of the forces that are acting onto the ball? So the result will be there is 5 Newton downwards and there is a 2 Newton upwards. So again, by choosing a scale, by using vector, okay, in terms of vectors, so you need to choose a scale first because it requires you to draw. Let's say 1 centimeters represents 1 Newton again. You can choose any scale that you want, but we are trying to go with an easy choice of a scale. So you have a 5 centimeters line which is being drawn downwards. So it will be 5 centimeters in length, and the end of it, so since this is the starting point, so this is the ending point at the bottom, So join it with the 2 Newton force, but in this case it is acting upwards. So it should be drawn 2 centimeters in length. So now we have our ending point to be somewhere above here. And what is the length from starting until the end? This will be 3 centimeters. So as a result, the resultant force acting onto the ball will be equals to 3 Newton downwards. And if you would like to do it mathematically, so we assume, first of all, assume downwards direction as positive. You can assume upward as positive, but since 5 centimeters is larger downwards, so we use the downward as positive. So that is the assumptions that you can make before you decide on your direction, the final direction. So once you know your final direction, your directions already set, now you do the calculation. So 5 centimeters downwards, so it should be a 5 positive, add on with 2 centimeters or 2 Newton upwards, which will be negative 2 Newton. So as a result, you will end up with 3 Newton. And since it is positive, and positive is your direction, which is downwards, so you can say it is downwards. So in that way, you can actually visualize the idea of vector of forces in the basic of it. The basic means they are both acting in either the horizontal direction only or the vertical direction only. You can visualize the whole idea in terms of vectors by drawing the lines and arrows, bearing in mind that your lines, when it involves drawing, you must use a scale. You must set a scale yourself, or the scale may be given by the question. So by setting it up and drawing it accordingly, you may get your resultant force that is acting onto the object. So let me clear this one up. It's a bench, so wrong spelling, I'm sorry about that. And yeah, that will be about it. I hope you have got a good idea about resultant force for forces in opposite directions. So in our next video, we will be learning about resultant force for forces which are acting in different directions. So maybe one is acting to the right and one is acting upwards, or one is to the left, another one is downwards. So how can we find the resultant force if the forces are acting in different directions? So I'll see you guys again in our next video. Thank you.